Hello and welcome back to Mr. Powers Teaches Algebra. We've been talking about series, and now we are on geometric series in particular, and we would love to get, or at least derive, the formula using it's easy, but deriving the formula and figuring out why there's a formula that works, that's a trickier part. So, without further ado, let's find a formula for finding S sub n. And after that, what we can do is let n approach infinity, get really, really large, and see what happens. And I think you'll see very nice result. So, S sub n equals a sub 1 plus r times a sub 1 plus r squared times a plus 1, so on and so forth, till we get to r to the n minus 1 times a sub 1. That is going to be in terms of a general geometric sequence. And we know this because we divide any two terms and we get a common ratio, in this case r times r times r times r, and so on and so forth. What we want to do then, and this is kind of a magic trick, kind of like with the arithmetic sequences, we had a little magic trick, like, oh, let's just rewrite it backwards. In this one, what we're going to do is multiply times the common ratio to get a new expression. And we'll get r times s sub n is going to equal r times a sub 1 plus r squared times a sub 1, so on and so forth, which is still a geometric sequence. It's a little different now. But no, what's really cool is that if we subtract one from the other, so I'll hit minus, and of course I'll have to subtract all of the right side, so we'll just put a negative in front of everything. Negative, 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 negative. What we'll get is a really nice result if we subtract or add the negative. All right, so check this out. Of course, on the left, we're going to get s sub n minus r times s sub n. And that's going to equal, well, let's see. R times a sub 1 is going to, or negative r times a sub 1 is going to cancel with r times a sub 1. Negative r squared times a sub 1 is going to cancel with positive r squared times a sub 1, and so on and so forth. There's a term in here somewhere. And we know this one comes right before r to the n times a sub 1. So that cancels with whatever came right before that. So all of these cancel. Everything after the a sub 1 cancels with everything before the r to the n a sub 1 there. And so what we end up with is just the a sub 1 minus r to the n a sub 1, which is really neat. It's a much simpler looking thing. And let's see if we can get s sub n by itself, because of course that's what we're really trying to do, is get a formula for s sub n, our partial sum of the first n terms of a geometric series. Well, I can easily manipulate the left side here. If I factor out s sub n, I'll have 1 s sub n on the left, and it'll be 1 minus r. And on the right, I'm going to go ahead and factor out an a sub 1 also, just because I'd like to have that in one spot. So I'm going to hit a sub 1, and this will be 1 minus r to the n. Nice. And now we have one step left. In order to get s sub n by itself, we'll divide by 1 minus r on both sides. And we have a general formula that is definitely true, definitely works. F sub n will equal a sub 1 times 1 minus r to the n divided by 1 minus r. Now we have a formula. Well, we have the formula. I mean, probably. It's easy to look up. But now we understand, or at least we've proven why the formula works. And you can try this with some small examples, little like 5 terms, 6 terms of a geometric sequence and do it manually a few times to really convince yourself. But this does definitely work. Now I'm going to write something a little weird. What if we're adding an infinite sum? And so in other words, I want to know limit as n approaches infinity of s sub n. So in other words, it's an infinite sum. And the way we just like to write s then in that case. And what we'll get is, well, if you think about this, r, we're going to have an r to the n, right? We have this r to the n in our expression. Now, if absolute value of r is greater than or equal to 1, r sub n is going to be approaching infinity. I shouldn't really write equals infinity, but it's going to get really large, really huge, really fast. And so the whole thing is just going to blow up. It will, what we say, we kind of say it diverges. We would say our series diverges, if that's the case. It does not converge. We can't get an actual value for the sum. And so we wouldn't even bother trying to find a sum for all the terms in a geometric series if r is greater than or equal to 1, or the absolute value of r is greater than or equal to 1. However, if r, on the other hand, is less than 1 and greater than negative 1, so it's in between negative 1 and 1, then that means r to the n is going to be pretty much 0. Because what are you doing? Easy example to think of is a half. If r was a half, 1/2 squared is a fourth. Then you 1/2 times 1/2 again is 1/8. Times 1/2 again is 1/16. It gets small really, really fast. So something less than 1, when you multiply it, you get a smaller number than what you started with. And so that's the thinking here. And so this guy, we're going to go ahead and say let r be less than 1 and greater than negative 1. If we let that happen, then we can do this. And we'll get a sub 1. Well, this r to the n is going to approach 0. So 1 minus 0 is 1. So what we'll end up with is that whole thing disappears. We just have a sub 1 on the top over 1 minus r. And that's going to be the sum of an infinite series if our common ratio is between negative 1 and 1. And there you go. We got both our formulas. The things we got to remember for both of these, is for both of these guys here, okay, is that a sub 1 is our first term. N is the number of terms. And r is our common ratio. That's all we need in order to compute or evaluate these partial sums or infinite sums now of geometric series. And that's all I needed to show you. It's all I wanted to show you. Hopefully this was helpful. Until next time, enjoy doing math.